All right, folks, so we're continuing our discussion of estimation here, and we're in the section called Estimating Population Mean, which corresponds to assignment 2122. It's one paper worth a double, 24 points. And so, you know, it makes sense to start with example 1. We might bounce around a little bit within this, but we'll cover every conceivable scenario. So we had a study of 64 U.S. teenagers. So I hope you would agree that would be considered a sample. And it says, kind of an outdated example, that on average, that group of 64 teenagers sent 3,339 text messages per month. That's the mean of a sample. So I want to remind you that that symbol would be X bar, wouldn't it? The mean of a sample. So the overarching idea here is this. We've looked at this many times. Point estimates. See, the overall idea would be to estimate the average, the mean, number of text messages sent by all U.S. teenagers. That's a population. We're never going to know that number for sure. That's why we're estimating it. But we're going to take that statistic from our 64 teenagers, that X bar, and use it as a starting point to estimate what it would be for the whole U.S. population of teenagers. And so again, here's our symbols, the mean of a sample, the mean of a population. In this series of examples, we're using the mean of a sample, called X bar, as a starting point to estimate the mean of our population, which is called mu. So there we go. We're using our sample statistic, X bar, to estimate our population parameter called mu. And that's really the focus of this particular section. You know, in full context, we also did proportion on a previous assignment, and then variance could also be the characteristic we're measuring. But the point is, this whole series of examples will be estimating a population mean using the mean of a sample as a starting point. So the average number of text messages sent by that group of 64 teenagers is X bar, isn't it? Okay, so we're estimating a mean, and this question goes on to say, find a confidence interval, in fact a 90% confidence interval for the mean for the entire population. Again, hit pause and read the whole question if you need to, if I get going too quickly. That's one good thing about this format is you can actually pause. But anyway, confidence interval for a mean actually has a flow chart that we need to talk through, and I can't say this enough. The thing at the top of the slide is the most important thing, which is to determine the standard deviation. There's two possible formulas when you do a confidence interval for a mean, and it depends basically on where the standard deviation came from. And I want to remind you that a population would be language like all and every and things of that nature, and then sample would be a relatively small group. So the question here becomes, when we go back and read the question again, we're going to focus on the term standard deviation, and we're going to look at the language that surrounds those words to see if the standard deviation is for the entire population of teenagers or just for that sample of 64. That's the first question. I have to admit to you, I don't teach reading for a reason. So when I read this, I'm going to look for standard deviation, and I'm going to see what words surround it. Here's what I'm going to tell you. Read the sentence that says standard deviation and see if you can figure out if it's the population or just a small group. I'm skimming here, and I find the words standard deviation right there. So I'm going to backtrack and begin reading the sentence that has the words standard deviation in it, all right? So let's backtrack here, and I think that sentence begins right there. And when I see words that are important here, be careful. If I see important words, you know what I happen to do, so don't take a drink or eat or anything, because I might scare you here. All right. Again, the question is, where did the standard deviation come from, a population or a sample? Find the 90% confidence interval for the mean monthly text messages for U.S. teenagers when the population standard deviation is known to be 126. Look, we tried on that very first one to make it very obvious that this particular one, the standard deviation, was for a population. All right? I don't know what else to do. All right? It was right there. The word right in front of standard deviation was population. It wasn't for those 64 teenagers. It was for all teenagers. Population standard deviation. Anyway, if it is a population, then you check to see whether you're told that it's normally distributed. Is the variable normally distributed? And so I will just tell you that particular question, you're probably going to need to see the words normally distributed in the question. I've seen it before. Keep reading. I don't think you'll see the words normally distributed ever in this question. So I believe the answer to that next question on the flow chart would be, is it normally distributed? No, I don't see it. No. Okay? Now, if it was normally distributed, then this would be our formula. But we can't say that yet because it did not say anywhere in the question that the population is normally distributed. So I'm not writing that formula in the box yet. It did not say in the narrative that the population is normally distributed. Those words weren't in there anywhere, normally distributed. They weren't in there. Go back and read the question. They're not there. So no. So then we ask, is n greater than or equal to 30? I want to remind you that n is sample size. How big was the sample? 64 teenagers. Is that more than 30? Is that greater than or equal to 30? Well, yes. So guess what? We got to that formula through this side door, and we can write that formula there. So there we go. This, in my opinion, this series of examples, it would be really important for you to watch these examples in sequence because I'm going to build out that flow chart from one example to the next. All right? So, this followed the first series of animations that I put in there. And even though you have a printed full slide that has this, I want you to think sequentially. That's what's important. Start at the top, ask each question, navigate your way to the appropriate formula. All right? So once again, we were told in the narrative that the standard deviation was from a population. It never did say that it's normally distributed, but we did sample at least 30. There's our formula. Write it down. My experience has been finding the right formula has been the challenge. And I apologize if my explanation doesn't click. I'm doing the best I can. It's really hard to tell if you're understanding, obviously, the way we're doing this. But we'll do as many examples as we can. Now it's important to understand what these symbols are. So we've already written down that X bar is 3,339, so that'll go right here. That was the mean of that sample. The average number of text messages sent by those 64 teenagers. All right. Sigma, I want to remind you, is the math symbol, this thing here. I'm going to skip Z for a minute, okay? Sigma is your population standard deviation. That's the symbol for that. And if you go back and read the narrative, it says, population standard deviation is 126. That goes in there. N would be the fact that they sampled 64 teenagers. And then, look, this Z-score would be obtained in the very same fashion as when we did the previous assignment. All right? So, here we go. That Z-score there would hopefully make you think of the standard normal bell curve with 0 in the middle. And hopefully this discussion now is going to sound familiar to you. This has to do with the level of confidence that the person desires, 90% confidence interval. So if you recall, we took that 90%, which I want to remind you is also 0.90, and we want the middle 90% of the bell curve, so didn't we cut that in half? 0.90 divided by 2. Look, that's kind of baked in here, alpha divided by 2. 90% divided by 2 in this case. And if you cut 90% in half, that creates 2 middle slivers, how exciting, of 45%. and 45% middle sliver on both sides, at which point you go, hey, table, got a picture for you. 2 middle slivers, 45%, perfect. This is the middle sliver table. This is the perfect table for confidence intervals, because when you cut that level of confidence in half, you're going to get 2 middle slivers. And that's what this table wants, right? Table want middle sliver. So basically, I'm pretty sure, let me put 45% here, 0.4500. I'm fairly certain, because I've seen this one before, that the 2 surrounding probabilities are 4495 and 4505. I want to remind you that that is obtained by reading the body of the table, and the 45%, which is otherwise known as 4500. I know it's hard for you to see. Pull out the copy you have in front of you. Have one of these ready to look at. That's between 4495 and 4505, and it's a tie. It's 5 units away from both of them. So this would be the scenario where you take the 2 z-scores that line up with those, 1.64 for this one and 1.65 for this one. And since it's a tie, isn't this 5 away from both? There is no closer one. Then you add them up and divide by 2, and that'll be 1.645. And that's the number that goes right here. 1.645. Probably heard my phone. I think that's my math agent trying to call me here. He probably has another endorsement contract for me. All right, but anyway, much like the previous assignment from here, we'll say, if I was going to guess the total number of text messages sent by all teenagers, I would start out with the 3,339 per month, give or take, plus or minus, and I'll remind you that that number that follows the plus or minus is what we call in statistics the margin of error. So, I hope I did this right. If you crunch all that out, this is about 25.9. Okay? As far as where you round it there, I don't care terribly. All right? Let's call it 0.91. There's more digits after that. I'm not going to make a big deal where you round these. I'll be able to tell if you did this correctly. And then, much like the previous assignment, do these in order. They build on each other. But if you're going to make this into an interval, wouldn't the low end of our estimate be minus? So we'll take this minus 25.9, and the upper end of our estimate is when we do plus, right? So anyway, I did that math ahead of time, and what I will also tell you is that following each example in the PDF, these examples, I have the answer typed up, all right? But if you do the minus, you get the number 3313.09, and if you do the plus, you get 3364.91. And that should be labeled as a 90% confidence interval. Okay? So, and again, I believe what I'll be doing in the future is, I feel once I get you to here, maybe even here, you can do the minus and the plus to get your interval. And if you can't see it on the screen on the video, it is, I believe, on your PDF that was sent to you following each example. We'll have the final answer here. All right? I better go answer this text from my agent. Again, I may or may not be back depending upon the value of the endorsement contract that I'm about to sign. Okay?